Hello, in this lesson, we're going to continue to derive and prove some very useful identities, which you're going to need in the future. Okay, yeah, also for this course. And last time we have proved that cosine A plus B equals to cosine A times cosine B minus sine A sine B. Okay, and today we're going to prove a couple more or in this lesson, we're going to prove a couple more useful identities, okay? And then the next one is going to be, what would it be if we have a cosine A minus B? Right, so we have cosine A plus B. What would it be if we have cosine A minus B? Okay, the way we prove this to derive this is the following. Okay, we'll look at cosine A minus B as cosine A plus minus B, negative B. Okay, and then we can follow the formula, okay, which is A matches A, B matches negative B. Okay, all of these are symbolic, remember, they are symbolic, okay? So to help you see better, you can use different symbols if you wish. You can use different symbols, okay? But let's try this, okay? This will be most straightforward. So here we're gonna apply cosine A plus B. So we have a cosine A plus a parenthesis, okay? So just think of this as negative B. I'm going to assume that to be omega, okay? So here, I will have omega equals to negative B, okay? And then we apply the formula, okay? We apply the formula and the formula goes like this. Like that, okay? So this becomes omega and B becomes omega and all B's becomes omega. Okay, it's just a substitution. It's a substitution. So here we're going to use that cosine A plus omega and substitute it by, substitute it into this formula, right? So we get cosine A plus omega. Since omega is negative B, so we're going to replace omega by negative B. Going to replace omega by negative B. Okay, so now at this point, be sure you have your paper pencil and do it along my side. So once again, cosine negative B is a cosine B because cosine is an even function. Minus, right, sine of A. Sine of negative B is negative sine B. Okay, so here we get a negative sine of B. So here we're going to put a note. Okay, we put a note here, which cosine is even, right? Cosine is even. So cosine of a negative B is equals to cosine of B. And the sine of negative B is equals to negative of sine of B. Okay, so that's even function and odd function properties. So as a result, our next step will get us to cosine A times cosine B minus, we have two negative sign here, so we have a plus sine of A, sine of B. Okay, so we have just proved that cosine A minus B is equals to that. So we have two identities in our study. Okay, two identities in our study. And these two identities basically lays the foundation for our future many identities. And many of those are very, very useful, very, very useful. Okay, so that's the first one. And the next one. Okay, and the next two identities we're going to prove, you have seen it, okay, are these two identities. These two identities. These two identities can be very useful because it basically write cosine in terms of sine, cosine in terms of sine, or sine in terms of cosine. Okay, so sometimes when you are in a situation that you have sine, you want to write it in cosine form, and we can utilize these two. Okay, so we're going to prove it. Okay, so here is the proof. To prove it, right, to prove these property, these two identity, we just need to apply, you know, the formula we just derived, right? Especially cosine A minus B, right? Cosine A minus B. So let's prove the first one. We will need this one. Okay, so I'm going to put it right here. Okay, so once we have this relationship, right? Cosine pi over 2. We don't know if this is true yet, right? So we're going to start. And cosine pi over 2 minus a. So we're going to apply this formula, right? So we're going to apply that formula. And of course, in our situation, pi over 2 is a, right? Pi over 2 is a. So we're going to put the equal sign underneath it. Equals to, so cosine pi over 2, pi over 2, whoops, multiply cosine of a plus sine of pi over 2, multiply sine of a. Okay, we know that cosine pi over 2 is 0. So the first term becomes 0. So in the end, we have sine pi over 2. Sine pi over 2 is 1, right? So what do we have? Basically, cosine pi over 2 is 0. So 0 times cosine a, that's going to be 0. Sine pi over 2 is going to be 1. So 1 times sine a is sine a. So in the end, we get sine of a. That is we have proved the first one, okay? So i.e. that cosine pi over 2 minus a is equals to sine a, okay? If sine a equals to cosine pi over 2, and here we're gonna do an interesting substitution, okay? Here we're gonna do an interesting substitution. I want you guys to watch this because we're gonna get to that place. Okay, so far of course, after you learn other formula, you can prove it other way, but here, provided that we just have that. Okay, so how do we prove this guy? Okay, now how do we prove this guy? Okay, we have already proved the first one. So now we want to prove the second one. From this expression, okay, from this identity, okay, so if this is true for any angle A, of course, measured from standard position and all that, right? Cosine pi over 2 minus A, if this is true, now I'm going to replace A, okay, I'm going to replace A by omega. So A is omega. Okay, so A become omega. And next, we're going to replace omega by pi over 2 minus a. So omega is replaced by pi over 2 minus a. So pi over 2 minus a will replace omega over here. Look, right? So it's just substitution. And then we got cosine. If we open the parentheses here, okay, so pi over 2, that's going to be pi over 2 minus pi over 2 minus pi over 2 plus a. So that equals to sine of pi over 2 minus a. Okay, and the left-hand side is going to be cosine of a, because pi over 2 minus pi over 2, that makes 0. So cosine a is equal to sine of pi over 2 minus a. So that's these two identities we were just going to prove. Okay. Next is that sometimes to memorize these two identities, which are very, very useful because we're going to use them for future identities that which are, useful formula. To memorize this identity, I think I'm going to show you a tip to memorize. These two. Okay, so I'm going to give you some tip to memorize these two. Okay, and these, I'm going to put them in a table. Okay, one for each. Okay, so this one and that one. Okay, so I'm going to give you some geometry tips, right? So far we have all of these, right? And we have also got that, right? So this piece over here and that piece over there. So we have 4 of these identities. Okay, but how do the tips to memorize the first one, okay? The second two are not so difficult to memorize once you have, you went through the step to prove it. Okay, we're going to use it so many times. Okay, so here I draw a picture. I draw a picture here to help us to memorize this. Okay, what it means is that on this unit circle, okay, and we have a terminal in the first quadrant, and we have a, provided that this piece is A. Okay, this is A. Because this is a right triangle. This is a right triangle, right? This is right triangle. So here, this is 90 degrees. And this angle, I'm going to mark it. Okay, this angle is going to be pi over 2 minus A. Okay, so that angle is pi over 2 minus A. So that angle and the other angle A. So these two angles are complementary. In other words, the sum of these two angles makes pi over 2 or 90 degrees. Okay, with that observation, okay, you can see cosine A, right? What is a cosine A? Cosine A is the blue. Wait, sorry, cosine A is a red. Okay, cosine A is a red. So I'm gonna make some marking about these. It's not really necessary, right? Cosine A is a red. So I'm gonna use these. I'm gonna use a slightly different language. Okay, so cosine A Oh, wait, I think I have repeated. I have repeated these two identities, didn't I? Okay, I have repeated these identities. Hold on. These two should be different. Okay. Cosine pi over 2 minus a is sine a, and there's a sine pi over 2 is cosine a. Sine pi over 2 is equals to cosine a. I'm sorry about that. Okay, so that's where it should be. Okay, we don't want to repeatedly type the same one, right? So now, so what you see is that we know the definition in geometry, right? In geometric definition. In geometry, this is A, this piece is A, right? And this angle, right? This angle, I'm going to mark it as over here. This angle is pi over 2. Let me write it down. Pi over 2 minus A. Okay. And since hypotenuse equals to 1, hypotenuse equals to 1, right? So what we have is that sine of A, sine of A, sine of A is the blue. Cosine pi over 2 minus A, which is the adjacent side, is also the blue. You follow me? So let me write it down. Let me write it down. On this unit circle, right? Sine of A is the blue. Okay. Cosine pi over 2 minus A, cosine pi over 2 minus A. So this angle is the adjacent side divided by the radius, okay, which is 1. So that is also equals to blue. So that's why cosine pi over 2 minus A is sine A. So that's how we get the first piece. So thus, cosine pi over 2 minus A is equals to sine of A, right? For the same reason, right? On the second piece, cosine A is red, right? Cosine A is red, the red piece, right? And sine of pi over 2 minus A, which is this angle, is the opposite over hypotenuse. So sine of pi over 2 minus A, okay, is also the red. Okay, thus sine of pi over 2 minus A is equals to, oh wait, I missed the equal sign here, is equals to cosine A. Okay, so hold on, let me wait. Okay, so I'm going to rewrite that piece. Okay. Sine of A is the blue piece. Okay. And the cosine of pi over 2 minus A is also the blue piece. And therefore, cosine pi over 2 minus A is equal to sine of A. Okay, so that's that has proved these two identities, which are very, very useful. Okay, the usefulness of these two identities, as I mentioned earlier, is that if you want to if you have something in sine, and you want to express it in terms of cosine, and you can utilize this identity. if you have something in sine and you want to convert it to cosine, you can use this identity. But sometimes it's a little bit difficult to remember which one is which. So this trick in this triangle, I have shown you how to, make sure you get the right formula in case you need them, okay? Once we have these four, now we have four formula now, right? We have four. So what are these four? So these four are, right? All of these. Okay. And next I want to show you our roadmap for this process of deriving. Okay, so I'm going to show you a roadmap. The roadmap I'm going to show you is going to be, it's in your homework, okay, in the module, okay? In the module for week 7. Okay, in the module on week 7. All right. Now you see trig formula, a diagram. So I'm going to open this file and show you. And this diagram is a PDF file. Okay. I made this diagram myself. Okay. So I'm going to show you the roadmap about what we are about to do. Okay, what we are about to do. Okay, so far, we have proved this identity, right? That's the first one we proved. And then we proved, so this is the first one. This is the first one. Okay, this is number 1, right? We proved the first one. From number 1, we proved number 2, which we did it in this lesson, right? And then what else did we do? We're going to take these two. Okay, so you can see I put arrows from number 1 to number 2, and how we get to number 2, this method is being specified, basically substituting what is in cosine a plus b by a minus b, and write it as a plus negative b. So that shows how to. And then today we have also proved this identity and that identity, right? That's what we proved today. And afterwards, okay, after this, right, we're going to prove that sine of a minus b and the sine of a plus b. Okay, it actually doesn't matter which one, okay? Whichever one comes first, and you can prove the other one. After all 4 in the middle are proved, and then we're going to derive the double angle formula for sine, the double angle for cosine, okay? And these two formula, which is the byproduct of double angle formula, very, very useful in Calc 2. Very, very useful in Calc 2. And now from the double angle formula, okay, from the double angle formula, from cosine, this double angle formula, right? Cosine double angle, we not only could get these 2 very useful ones, and we can also derive half angle. So these are the half angle formula, okay? And now, so this is the branch on the right. On the left, we are going to operate from these 2, okay? By adding, subtracting, we will get this piece. And from this piece, we get to the next 2 pieces on the top. You can see the arrow, right? All these arrows indicate the direction of operation and how to, okay? So plus minus is how to. And plus minus of number 1 and number 2, we also do adding, subtracting, and we get product to sum or difference. And from these two, we also get to from sum to difference to factor form. So now you can see the roadmap, right? And you can change from product to sum or difference, which you often need it in calculus 2, and from sum or difference to product. And sometimes you need that in solving equations, say calculus 1. Okay, so each has its purpose. So let me mark some notation. Okay, mark some notation. So here, these two, it shows from product, okay, to sum or difference. Okay, to sum or difference. And this one too. So this piece and that piece is about product to sum or difference. And this piece is about sum or is actually about factoring. Okay, so these two formula is about factoring, and of course this one is also about factoring. Okay, we know that the factoring techniques is something we have learned since algebra, right? Since algebra, we have many applications, especially if you look at the 6 mathematical principles, right? How many of them are related to 0? Right? I know number 6 is related to 0. Number 5 is related to 0. And you know, there's more than that, right? So number 5 and number 6, principle number 5, number 6 often calls for product. Because if we have product, then we can sometimes use principle number 5 or principle number 6. Okay, so we will explain these ideas as we go through our study. Okay, because we still have many weeks to come. So this week, the first part of this week is we're going to focus on deriving these identities. So when you're watching these recorded lectures, please make sure you have your notebook, paper, pencil with you. As always, you know, you should have done this before. If you haven't, please get started doing so. And we're going to go just deriving them. The purpose of this deriving process is for you to never have to memorize them. You will not need to memorize them if you go through this process. Okay, I've gone through this with my classes, and those students who participated in the process and really work on it, they all come back to report to me how well this process have helped them. Because in this process, you also see how certain actually they're pretty simple algebraic techniques are being used in the process. Okay, so this is the roadmap I've given you, and you can just follow the arrow, right? So we are going to follow the arrow. So next lesson, we're going to go from here. We're going to go from here, and we're going in that direction. We're going to derive these. Okay, we're going to derive these two. Okay, thank you for watching. Until next time.